Okay, first one. If you're ever asked to describe a data structure, tell me about the data structure. So a linked list, the key thing about a linked list that distinguishes it from most of the other data structures, it's a dynamic structure. Quite a few people kept saying it was ordered. It isn't in sequence. The sequence is just the links. We can order it and then maintain that order, but that's not what defines a linked list. So it's a dynamic structure, consists of nodes. So you're just describing what the structure is, not how it's being used or anything like that. So that is data, and a link is what a node is. And obviously data is dependent on an application. Could be one piece of data, it could be thousands of bits of data or whatever. And the other key feature of it is the nodes are linked together with pointers. To next node in that list. And the other thing you can say is we only ever know where the first node is, the head, don't we? Which is one of the things we always have to bear in mind. Only point to first node. The head of the list. You need, for any of these data structures like a tree or a graph, you need to get down just the basic, what is it? Not how it's used, just what is it? So that we can do that. 3 marks for that. Right, this next question, most people got some marks on it, which was good. Okay, some people really went a bit wrong on it. Right, so we've got a linked list. It's got an order in it. The order is the order that we're visiting the locations. Okay? And they want us to, what do we do? We're going to remove Birmingham. Explain how it's removed. Right. If you're given a diagram, always edit the diagram. So in order to remove Birmingham, we're not going to delete it. Remember, these are just in memory. Quite a few of you were saying about arrays and indexes. No. No indexes. We have got pointers to memory locations. We don't actually know where that memory is. Okay? So if we want to delete Birmingham, what we've got to do is go, right, okay, so Birmingham points to Manchester. And then I'll show it visually. I can't spell Manchester, I wonder why. Right, Birmingham points to Manchester. So if we make the thing that points to Birmingham point to Manchester, it will get deleted. So Oxford points to Birmingham. Why did they pick such big town names? They could have made little names. So if we change the pointer of Oxford to point to Manchester, Birmingham is skipped. So change Oxford to point to Manchester. And that will remove it. We don't need to delete it. Right, so visually showing that, all you're going to do is you're going to say that pointer now points to Manchester. That's it. That's one of the nice things about linked lists. Deleting something is just change a pointer. You don't move things. Some of you, because you were talking about arrays, started talking about shuffling things down. It's like, whoa, no. It's not an array. You can see it's not an array because it's distinct elements. The nodes are distinct and they're joined with the pointers. Now, they want to add a new location, York, that's going to come after. So the first thing we must do is we must create a node for York. Okay? with a null pointer, because it's not pointing to anything. That's your first job. How we do that, if we're using one of these array structured ones where we've got a table of data, then yeah, we'd look for a free space. But if we're just creating a node, asking the operating system for space to store something, then we'll just create a node with a null pointer. We want it to follow Manchester. Right, so what we do is we say, right, say, we set Manchester to point to York. Okay, and even though we've already set it, because Manchester pointed to null previously, that's what York has to point to. Oh, let me scroll up. And that's it. Graphically, all you've got to do is create a node with York in it and a null. So you could actually get all the marks by just doing the diagram bit. I'm going to put a -1 because I can't write null in that box. I made it too small. Right, so this pointer now points to York. And that's it. That's the beauty of linked lists. They're inherently simple, but it does have a consequence. Okay, and then the final part of this question, right, this is a question about data structures. It's asking you to compare data structures. Don't start talking about anything that you can remember about hash, what the word hash means. A load of you start going about security and how more secure it's going to be. No, it's about data structures. The relative benefits of a linked list against a hash table. Right, it specifically says they're going to increase the number of customers. We want to be able to look things up, i.e. search. There is one Achilles heel with linked lists, and that is the search. So we would say linked lists is linear search. At best, it's sequential search if we got a sequence, but we haven't in this case anyway. It is a linear search. So that involves going through all the items. As numbers increase, linear search gets worse. What do we put for big O for that? For linear. It's not the word. No, that's quadratic. That's where it like really rapidly increases. No, so for this it would be ON. As we add more items, it has an effect on the search. Remember, these are estimates, this big O stuff. So it doesn't directly tie to anything, but it's just like saying, yeah, there's a linear increase in time. Okay, so that's the again, yeah, linked lists. Hash tables, the big O for that is O1, which I think one person quoted. Okay, that means it's constant. It's a calculation, it's a function, isn't it? Constant time. It's just how long does it take to run the function that calculates the hash. So it doesn't matter how many you've got. So it will not increase time taken to search. It's not really a search, it's a lookup. I'm going to put search in double quotes because it's a lookup. It's driven completely by how long the hash function takes.
But surely they have to compare that
Oh yeah, no, that's the decision you got to make. I mean, you got to say, well, what's the maximum number of elements? If I'm going to store 20,000 customers, if I have to do a linear search, it's just not going to work. It depends, because they haven't given really a context for this, have they? They said about this customer thing, but they haven't. There's no scales, is there? The hash algorithm will not take very long to calculate. It will get hit by collisions, and a few people mention that. Okay, so collisions is a factor, but not a major factor. Especially if you use the proper overflow method with the linked list, which is ironic. A small factor. But nothing compared to a very long linear search. Okay, right, I'll start that one.